Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The sulfite dianion SO3 has the structure with sulfur bearing a lone pair, 1s is equal to O, the exocyclic oxygen giving the dianion its charge distribution, and 2 SO bonds. The key question is which site, oxygen or sulfur, acts as the nucleophile site of protonation or alkylation. Moving on to the next step. The sulfite ion SO3 shown as OS is equal to O dash has sulfur as the central atom with a lone pair. It is ambident, it can react at oxygen, O attack, or at sulfur, S attack. Moving on to the next step. Protonation is thermodynamic kinetic and occurs at the more electronegative oxygen atom, O protonation. This gives OS is equal to OH, which is the bisulfite hydrogen sulfite ion, HSO3-. This matches option B as first product, OS, is equal to OH. And for the final step, alkylation with soft electrophiles like alkyl halides, CH3I, follows sub-theory. CH3I is a soft electrophile and sulfur is a soft nucleophile. Therefore, S-alkylation occurs, giving a product where CH3 attaches to sulfur. The sulfur, now bonded to CH3, O dash, is equal to O, and still one O results in a zwitterionic charged sulfur species, OS+, is equal to O dash, CH3. This is methylation at sulfur, producing methyl sulfonate type species with a positively charged sulfur bearing O dash is equal to O, CH3, and maintaining the other O dash. This matches option B as second product, OS+, is equal to O dash, CH3. Option A shows O methylation for product B, OS, is equal to O CH3. But CH3I being a soft electrophile prefers S-alkylation over O-alkylation. Incorrect. Option C shows O-methylation for A and S-methylation plus H on S for B, which is inconsistent with protonation giving OH product. Option D shows protonation at sulfur for A and O-methylation for B, both incorrect by sub and standard sulfite chemistry. Therefore, the correct answer is B. Therefore, the correct answer is option B.